Hi everyone. Welcome to our webinar today and thank you so much for joining us. It's fabulous to see so many people online. I am Claire, the CEO of Smart Creek Cooperative Research Centre. I'm very pleased to see so many of the people in our network joining us today as well for a fantastic conversation on performance-based specifications and what that means for us as a sector. Here at Smart Creek CRC, we're really looking for those big meaty challenges that we can solve together as a network, so things that are highly collaborative that can take a research-based approach to create the innovations and new knowledge and insights we need to move towards a decarbonised future. So really excited that we could all come together today to hear from some leading experts in our sector about what performance-based specifications means. Before we get started, I'd really like to acknowledge the traditional owners on the lands on which we all meet today, noting that we are right across the country as we join in today. I'm very lucky to be in beautiful Melbourne today, and I'd like to pay my respects to the Wiradjuri people who are the traditional custodians of this land. I think when we're thinking about the future of our built environment, it's really lovely for us to think about the custodianship that our traditional owners have for this land, water, air, and how they can continue to help us drive a sustainability message in our sector. So pleased to recognise elders past and present. We have four really fabulous speakers for you today. So we have Jason Nan, who is the Director of Research and Technology at Cement, Concretes and Aggregates Australia. We have Bruce Perry joining us from Cement Australia. He's the National Technical Support Manager. We've got Robert Sabraya, who is Head of Policy at the Australian Contractors Association. And we have David Kelly, who's the Acting Director of Engineering and the Sustainable Infrastructure Program at Transport for New South Wales. So this should be a really fantastic discussion about what performance-based specifications means. And to tell you right up front, this is a first step in a program of conversations that we'd like to continue to have with you about the challenges towards performance-based specifications. And so we will be running directly following this within about a week or so, we'll be running a workshop where we look at bringing people together to really flesh out this conversation a bit further. So we'll have a link at the end of this webinar to register your interest for that workshop. So we're hoping this might spark a little bit of enthusiasm to get that workshop conversation started. So just quickly again to acknowledge our fabulous speakers today. Thank you so much for joining us. We have them all online. We do actually also have a little exercise for you as participants in this webinar today. And what we'd love for you to do is to log into menti.com. It's probably quite easy to do on your phone if you're watching us on your computer. But please join us as we go through this conversation. We have a few questions to ask you about your thoughts on this topic. So if you go to menti.com and then pop in the number 59037582. So I'll give that just a moment. The number is 59037582. I'm a bit like a bingo caller at the moment. 59037582. And you should see a question pop up on your screen. I will stop sharing now so that we can have the very first of our questions come up on screen. So just give it a moment. So we're really keen to hear what you think about performance-based specifications. We're just going to start off with a couple of questions. So very first question, which thank you so much. So many of you already have jumped into this. And again, if you're joining us just now, you can hop onto menti.com and the code is just directly at the top of the screen here. First of all, we would love to know where you're from. Who do you represent? Fabulous to see so many people from the supply chain online with us today. Awesome, thank you. And then we're going to hop into the first of the slightly hairier questions. Oh, I apologise. I'm being told that the next question is after Jason. There we go. I'm just running off on my own here. So it's my very great pleasure to present to you Jason Nan, who joins us from Cement, Concretes and Aggregates Australia. Jason, over to you.
Thanks, Claire. we need to load up our presentation, Jana.
It's just coming.
Just coming, does take a while. So while that's coming, I'd just like to thank Claire and Marguerite team. It's quite privileged to be able to present today to a big audience on this subject of performance-based specifications. It's certainly an area of interest from a sustainability point of view and for other reasons as well. And certainly it's an area of a little bit of complexity. So it's a really good area for collaborative research undertaken to determine the things that we need to do and information we need to use to actually employ performance-based specifications in the construction industry, particularly for concrete. So I'll get onto it now. So performance-based specs, really, this opportunity is to talk about the knowledge gap, or what is performance-based specifications for concrete. What are the knowledge gaps? How do they apply and benefit the ambition towards improving circular economy and decarbonising our industry? And I'll go on from there. Should be. There we go. I do have it. So quick chat about concrete. What is concrete? Why are we interested in concrete from a sustainability point of view as well? A bit about the two key areas of interest for us in sustainability, which is circular economy and decarbonisation, two major ones. Let's talk about a conversation about standard specifications. What's performance-based? What's prescriptive? And how do the two work together to form the hybrids? And then a bit of a discussion about, from a concrete point of view, if we're going to provide some performance-based alternatives into prescriptive specifications, what are the areas of interest that we are? We're not going to come up with the research projects here or exactly the answers. It's really an awareness session about the specifications and standards and how they apply to concrete. All right, concrete. So our favourite material, it is the most popular, by volume at least, construction material that's used in the world. Around 29 million cubes used in a premix concrete, at least in Australia, from around 1,500 batch plants. It's about 70 million tonnes of material, 10 million tonnes of cement, 55 million tonnes of aggregates, 3 million tonnes of SEMs, and a little bit of water to mix it all together. So as a result, we do use a lot of those materials. There's a really important focus on sustainability to ensure that we're using those resources efficiently and that we are minimising any of the impacts of extracting and using those resources. The two areas of interest really for us that, and I think you'd have to be living under a rock at the moment not to hear about circular economy or about decarbonisation. So from a circular economy point of view, we're very fortunate in our industry that while we do extract and use a lot of materials, we're not large waste generators. Nearly everything we take out, we use in making concrete, and somewhat we're a net consumer of waste from other industries. For example, we use about 3 million or so tonnes per year of supplementary cementitious materials that come from blast furnace waste products from iron blast furnaces or from coal burning power stations. In a concrete plant, when we come back and wash the concrete trucks out, we capture that water and we recycle that for making new concrete. In a quarry point of view, we take the quarry fines that would otherwise not have a market and transform that to produce manufactured fine aggregates or manufactured sand to replace otherwise natural sands. We also bring in a lot of aggregates from other industries such as air-cooled blast furnace slag, and there's a huge growing list of otherwise waste streams such as recycled crushed glass, where that glass can't be used to make new bottles, which is the real value, to be used as a replacement again for natural or manufactured sand. But also concrete is 100% recyclable. We can reuse concrete at the end of its life to either make new concrete or to use in civil applications. So it is a great opportunity to improve that circular economy, and research and working with specifications and standards is the way to ensure that we're using these materials as best as possible, but with the lowest risk as well. As an example, there's a lot of waste materials that are used, and really they're supported by end-of-waste codes or resource recovery codes in New South Wales, supported by standards and specifications, including testing and guides and handbooks. there's a lot of work been going on for a large number of years now to encourage the use of otherwise waste materials to replace the virgin materials, and that continues now. For example, the Austroads have undertaken some work recently around solid crushed glass. They produced a guide for how do you process glass fines to produce an RCG, or a solid crushed glass, suitable for construction use and for a range of applications. And then they've got a specification which tells you this is the quality requirements for the RCG to be used in different applications. And once you have those things, you know how to make it, you know what you've made, and you've got a guideline of a consistency. These specifications provide consistency. You can then undertake the desktop and lab and field trials to develop the use and to demonstrate the use, and finally make sure that those materials are incorporated into our standards and specifications. Again, it's all performance-based. If you've got RCG as an alternative aggregate and you've got a performance-based standard for making concrete, then the thing works really well together. A lot to build. The other area of interest for our industry is decarbonisation. People should know that the cement and concrete industry is responsible for a large percentage of anthropogenic CO2 emissions, and we've got a very strong ambition to reduce that CO2 footprint as quickly as possible, and with a target of net zero by 2050. As a result, there was a pathways document, decarbonisation pathways for Australian cement and concrete industry, produced the end of 21, produced with combination with Smartcrete, CIF, ourselves and others. And that comes up with 8 pathways, which all work together in parallel to get to that net zero by 2050. From a concrete manufacture, supply and use point of view, there's really only 4 pathways that really act in this area. Other ones that are about making clinker or electricity use, and about carbonation. And these ones are the way that we design and construct things, the way that we make the concrete, and the materials that we use, the SCMs and the cements that we use inside those concretes. And together those 4 give about 41% reduction of CO2 at the 2050 position, but will continuously go from now to that 41%. And those changes, when you look at those pathways, there's a lot of individual things that happen in their design method, structuralization, using less materials, in changing the way that we assess and test the concrete product. We're going from 28 days to say 56 days where appropriate. Changing the construction technologies to use things like go from cast in situ to precast, or go from pumped concrete to another way of delivering concrete. Reducing waste is important. Extending the life of the structures is important. Repairing those structures, reusing those structures, and then all the things about the cement. So you're looking at maximising traditional use of SEMs, but looking also at the new ones that are available, looking at reducing cement content, new alternative binders, both non-Portland cement ones and some new CO2 efficient cements. So these are the things in those 4 areas, or shortlist at least, that all rely upon then changes to specifications and standards to enable them to be delivered. So everybody knows concrete, it's very durable, very strong, it's very energy efficient, low cost. That's why we use a lot of it. And our structures are typically designed for long life, 50 to 100 years. But the standards and specifications that we do have are really important to make sure that our design requirements, that the structures that we make do meet all of the in-service requirements, and that they last for this long design life, the long service life. But there is opportunities in the standards and specs to further support the circular economy and support decarbonisation as well. When we look at standards and specs, those standards and specs really from a concrete point of view, and this is provide requirements for raw materials, about the mixed designs, what proportions of these materials you need in those concrete designs, about the concrete properties you want, plastic and hardened properties, the methods of construction, and overlying all of these things is the testing as well. And standards are also supported, support specifications and code. For instance, the National Construction Code is fully supported by a set of design standards, which is supported by a set of material standards, which is supported by a set of testing standards. And the standards and specs, they can be prescriptive, where they say this is exactly how you can do it, or they can be performance-based, where they say this is what we want at the end, and it's up to you to decide how to deliver that. But in reality, all the standards and specs are somewhat hybrid. So all have a little bit of prescriptive, a little performance, and the balance can change depending on which standard or spec you're talking about. Prescriptive specifications from a concrete point of view are really intended to deliver the required performance. And these are typically based on history or experience and knowledge, and they do limit or specify the types of materials that can be used. So that can be a limitation in regards to looking at new recycled material sources. They can limit the proportions of the materials that are in the concrete mixes, and that can set minimum cement contents and therefore have an effect on our strategies to decarbonise. They can set plastic properties of the concrete, slump or slump flow ranges, air contents. You can have test methods that are in there, and also the final properties. So performance-based specifications, on the other hand, really are focused on the important properties of the concrete, both in the plastic and hardened stage, that are required to ensure that the structure being built is going to meet its service and design life requirements. The benefits really are that it can be more sustainable. You can optimize your mixes to get reduced embodied carbon. You can improve material circularity and reduce the demand of scarce resources. It can be more reliable because it's based on model codes. It can be more optimum in that you can choose what materials you would like to use and optimize those relative amounts of those materials to deliver it. It can have lower variability for the same reasons. It's more flexible, and ideally it has reduced cost as well. But with each of these two distinct types of specifications, there are advantages and disadvantages of both. From a prescriptive specification point of view, they're really about the advantages are really about control and confidence. They're simple. They manage risk, and you don't need a lot of expertise to deliver to a prescriptive specification. If a supplier says, I need this much cement in my concrete, you make a concrete that much cement. That meets the other test requirements, and that's straightforward. But the disadvantages are that it does diminish the ability to optimize those mixes. It diminishes the ability to include new materials. Doesn't stop it, it just diminishes it. It just slows it down a little bit. Performance-based specifications, though, also have a number of advantages and disadvantages. And again, they're about control and about the opportunity. Is it other advantage? Testing requirements, but also it's more complex. There's disadvantages. It's more complex. There is a lot more work required in a performance-based specification to demonstrate that the concrete being delivered and used, it actually meets the final requirements. As a result, there is a lot of work that needs to research work and other work that needs to be undertaken collaboratively between the whole value chain to ensure that performance-based specifications are accurate, well supported, are reliable. The tests that we undertake that are different to the normal tests that we do, which aren't very complex and may be more complex, are undertaken accurately and reliably, so that you actually have a control of that concrete performance via that performance-based specification. But in reality, because there's advantages and disadvantages of both types of specifications, it's hybrid specifications that are the most commonly used. And for example, if you look at AS 1379, the manufacturer supply of concrete standard, this one does have some prescriptive requirements. It does say these are the materials you should use to make concrete to meet this standard, but it doesn't specify how much cement, for instance, you need to use to produce a certain concrete grade or certain concrete strength. What it does tell you is how do you sample it, how do you test it, and how do you assess those results to ensure that you're meeting that concrete grade. But most specifications, though, are a bit more conservative in that regards, and they have additional requirements such as minimum cement contents that's needed for a certain concrete grade, really about controlling durability. But there are lots of specifications as well that are also hybrid. Here's an example from B80 from Transport New South Wales. When we're looking at expansion of aggregates in this AR reaction, if you measure the aggregate under these AMBT and CPT tests, and you get a certain expansion, then there's some actions required, some deemed to satisfy actions to control that expansion, in particular use of SEMs. But at the same time, in that specification, under certain conditions, you can use those same tests and work out how much SEM you want to use, fly ash or slag in this case, to reduce those expansions below the level that is acceptable for concrete use. So that's a really good example of a hybrid. If you're not sure how to design it, follow the bouncing ball and the deemed dissatisfied rules. But if you've got some better idea to do it, then use the performance-based method to then give you a more optimized approach. I'm sure I clicked that then, hang on. So how do we go from prescription to performance? And really, it's about adding performance to prescriptive specifications rather than changing from one to the other. From a concrete point of view, there's really a number of key criteria. It's got to be structurally safe. So we're really interested in the hardened properties of the concrete. It's got to be able to be constructed. So we're interested in the plastic properties of the concrete. It's got to be durable. So we are interested in the durability of that hardened concrete. And it's got to be sustainable. We do the first two, structural safety and constructability requirements, in specifications and standards right now. We do have some specifications and standards that talk about durability, and we're starting to see circularity index and certainly upfront or embodied carbon come into the requirements for concrete supply as well. From a structural and constructability specification point of view, we have some very simple tests that we do in regards to the hardened concrete, typically strength, which can be used to predict other properties such as stiffness, modulus, flexural strength or shrinkage or otherwise. It's a very simple test. It's typically tested at 28 days. There's an opportunity to change that test date, to change it to a later date, take advantage of maybe 56 days where it's appropriate, and take advantage of the strength gain we get past 28 days that doesn't occur that much with straight cement mixes, but occurs highly with SEM mixes. Conductability is normally specified by a placement method and then an appropriate slump or slump flow. And again, on a performance base, what we're looking for there is to make sure the concrete is compacted. So maybe we could have a compaction factor instead of that, not the compaction factor test, but a degree of compaction that's specified there instead of those other requirements. But really, the big opportunity is in durability. It is in durability that prescriptive specifications probably are more popular. And in durability, we really talk about three ways that we control durability of concrete. We have avoidance. We have rules about don't do this, this, and this. And these mechanisms of concrete degrading won't occur. We then have deemed to satisfy rules like cover, reinforcement cover, and minimum concrete strength requirements. And then we move to things like service life models, probabilistic or partial subject factor service life models. Avoidance in DTS is really common in specifications and standards because the service life models do require a more thorough understanding. It's more complex. You need to have a durability indicator test. You have a service life model you have confidence with, and you need to understand the mathematics to ensure that you get the reliability that you're looking for. But there's plenty of service life models that are published around the world and being used. The FIB have in Bulletin 34 in the model code is a good example of that, and that model code is about to be updated this year. We do use service life models in our durability plans for large structures for checking or provide additional advice. And also service life modeling can be used to check things like deemed to satisfy or avoidance rules to make sure those rules work. So they have a lot of value, is these service life models. Key to it, though, really is the test methods, the durability indicators. So from a durability specification point of view, we really need to understand what durability we're talking about. Is it exposed to CO2 and therefore carbonation, or is it exposed to seawater and therefore chlorides? Given that, what sort of accelerated test methods? We're not going to do a test method. If we're going to have a 100-year design life, we can't wait for 100 years to see if this is going to work. We've got to have methods that are accelerated but still reflect what's really happening in real life, but just gives us the result a little bit quicker or a lot quicker. We have to have service life models that we have reliability in, that they are mathematically correct, they've been proven in real life environments, and that we've got confidence in the reliability factors that we use in those. We also need to understand, are we talking about durability specs for quality assurance against quality control? And then given all those things, how do we include it into a specification to provide this performance-based alternative? These are all areas of thought for research. And finally, what are the opportunities? Well, the opportunity is performance-based construction, supporting circular economy and decarbonisation. There's a bit of a laundry list of things that you can think about is increasing the age from age of strength assessment from 28 days to 56 days where appropriate, where you're not going to load that structure early. Looking at limits of concrete shrinkage and making sure that they're applied where you need those limits, where otherwise the structure will have cracking or shrinkage that's not acceptable. Opportunity of use more recycled materials from different streams, increase the use of traditional SEMs and introduce the use of new SEMs, reduce cement contents where possible, and have the ability to use alternative binders, including these new CO2 efficient cements such as LC3s and things like that. But one of the things that underpins this for durability from a point of view, a lot of these things will be service life modelling and the determination of the appropriate durability indicators to measure the characteristics of that concrete. Thanks. Back to you, Claire. Oh no, back to Minty. No.
Thanks, Jason. That was fabulous. Really, really great overview. And yes, we're going to go back to Menti. I will just stop my sharing screen. So after that fabulous overview from Jason, our question is, why should or shouldn't we adopt performance-based specifications for concrete? You're going to get an opportunity to type messages. So it will come up in a little message box. So feel free to use full sentences. That is totally fine. We're keen to hear from you. What do you think, are the reasons why we should or shouldn't do this? And this will stay, if you're logged into Menti in the background using menti.com and the number that's at the top there, this question will stay available for our next presentation. So I'm really excited to hand over to Bruce Perry, who joins us from Cement Australia, who's going to be able to share a little bit of the supply side of the equation. Bruce, let me just share your slides.
Thank you, Claire. Okay, so yeah, just flick the second slide. That's fine.
There you go. You should have control of that too. Thanks, Bruce.
Oh, me, have I got control? No, just flick the second slide, Claire, please.
I'll do it. Let me just. That one?
Okay. Okay, thanks very much for the opportunity to come and talk to you. I'm going to just focus for just 5 minutes or so on some of the test methods for the assessing the durability of concrete. Jason touched very eloquently on the need for test methods to essentially supplement and support performance-based specifications. But it's not as simple as that, I'm afraid. And as you'll see in the next few minutes, some of these test methods do have some limitations which really need to be addressed in the performance-based specification. So the first one, okay, alkali aggregate reactivity. We're all very, very familiar with this phenomenon, not least of which up here in Queensland, where the infrastructure organisation has suffered hugely from a lot of support structures suffering from expansive reactions. The two test methods that are available today, AS 1141, 60.1 and 60.2, these are designed to allow aggregates to be tested for potential reactivity under alkaline conditions, which is in concrete. The accelerated mortar bar test is well established, as we all know. It can be carried out by numerous NATA accredited laboratories around the country. But the downside really is that this is an accelerated test. The concrete prism test is also an accelerated test, but it takes a lot longer to run to completion. I put there 2 years, but certainly within the first 18 months or so whether you're going to be on track for a successful result. So alkali aggregate reactivity is a durability issue, but it's fairly well established to be able to assess a particular source of aggregate's potential for causing expansive reactions. Next. Okay, next one, which is pretty close to my heart, having spent years working in this area, is the resistance to chloride ingress. We're namely talking here about C-class exposure conditions, mainly in the marine environment here in Australia, obviously in the Northern Hemisphere where de-icing salts are applied to concrete structures. There's another source of external chloride, but here in Australia, we really have to be worried about concrete near the sea. But bear in mind where we all live, that's a lot of concrete. So there are three methods which are generally accepted as being used to assess whether a concrete can resist the ingress of chloride ingress. Remember, once the chlorides get down to the steel reinforcing bar, that's when the issues of corrosion begin to occur. Jason touched upon modeling methods, life cycle modeling methods to predict how long it takes for chlorides to penetrate the covering concrete and get down to the steel. But these three methods are essentially designed to compare or evaluate a particular concrete's ability to resist chloride ingress. The first one is called Nord Test NT Bill 492, which is an accelerated test. And that is normally carried out when the concrete is just 28 days old. There are only 5 laboratories that are accredited to run this test across Australia, and we're only aware of 2, one of which is ourselves, the other is Ball in Sydney. It is a pretty tricky test to run. And so finding a laboratory to run this test is not an easy task. The 443 test takes a bit longer. That takes 3 months, or you actually test the concrete at 3 months. And this is more commonly run by laboratories across the country, but it's quite an expensive test. It's like $2,500 per concrete mix. And then finally, one here that's very commonly specified here in Queensland is similar to the 492. It's the ASCMC 1202. And only 7 laboratories are accredited to do this test. So we're not really sure how many of those are active. Okay, moving on. The shrinkage of concrete is a perennial issue with all concrete mixes. And historically, some specifying bodies have tried to limit the shrinkage of concrete by placing restrictions on the shrinkage of cement. And there is an Australian method for this, AS 2350 part 13. But really this shrinkage test for cement is irrelevant. And it puts constraints on cement producers to produce economic general purpose cements. Because at the end of the day, the concrete always has to pass the shrinkage test. It's not the cement that has to pass the shrinkage test, it's the concrete mix in question that has to pass the shrinkage test. Which brings me on to the next test. Claire, can you move on? Thank you. Concrete drying shrinkage. This is another accelerated test, and it's primarily aimed at concrete mixes that are used for pavements, floors, slabs, etc., and also containment structures, water retaining structures, even radiation containment structures. Now, this is an accelerated test that's well documented in AS 1012 part 13, but the test has really a lot of limitations, and not least of which is the fact that the results you get in the accelerated laboratory test really bears little resemblance to how a concrete element will perform in the field. Work done here in Queensland by Professor Peter Dutz and Alan Cars proved this years ago, that shrinkage numbers in a laboratory test do not correlate to how a concrete floor or a concrete element will perform in the environment. So again, when we talk about performance specifications, the test method really has to be relevant to what happens in situ. Okay, moving on. Okay, another quite a topical subject at the moment is the resistance of concrete to carbonation. Now, why is this a problem? Because there is a school of thought that says that concrete mixes with higher levels of supplementary cementitious materials, i.e. low carbon concrete mixes, are more prone to carbonation over a period of time. Now, the problem here is there are 3 test methods, the FIB method, the ISO method, and the EN method, 2 of which are accelerated methods. The European one, the European 12390 is a long-term test, but we're still trying to work out what relevance a result in an accelerated carbonation test has in the field. And the evaluation of this test method is very much in its infancy. Here at Cement Australia, we are able to run this test method, and we can't work out really what is a good result and what is a not so good result. And there's no cross-referencing yet available to how concrete performs in the field. But this is being addressed. We're working with an academic institution to try and work out whether there is a link between accelerated testing and field experiences. And then finally, the last one, which will probably raise a smile on a few people's faces, I'm sure, is the permeability of concrete. And one particular method, which is adopted a lot in Victoria, a little bit in South Australia now, and New South Wales, but it's the apparent volume of permeable voids, or VPV test. Now, this does have an Australian standard associated with it, AS 1012 Part 21, but even the standard itself suggests that there is no precision data available for this test method. And so what the Vic Roads do, they have to be very conservative with their approach. Okay, Claire, that concludes my few slides.
Fantastic. Thanks, Bruce. That was a fascinating insight, and I think really touching on some of the challenges already in terms of ensuring that we have correct and appropriate testing protocols. So thank you so much for sharing that. Next, I'm very pleased to introduce you to Robert Subraya, who is the Head of Policy for the Australian Contractors Association. I'll hand over to you, Robert.
Thanks, Claire. Afternoon all. Thanks for the invitation to speak to you today about this. It's a topic, well, the prescriptive specifications part of it is, or the performance-based specifications is a topic very close to our heart at ACA. This won't be a technical conversation. I still struggle with the difference between concrete and cement, so forgive me for that. Well, let me first introduce ACA. For those of you who don't know us, we represent the largest tier 1 construction companies in Australia. So all the big infrastructure builders are our members. And our job at ACA is to represent their interests and promote a more sustainable industry in the fullest sense of that word. Now, prescriptive specifications or specifications in general are quite problematic in many respects from a contractor's point of view. So, you know, it's pretty obvious to all of us that they largely determine what gets built and how things get built. And, you know, people often look at the contractors and say things like, well, why aren't you innovating? Why aren't you doing things differently? Why aren't you being more productive? And the response from a contractor might quite rightly be, well, it's pretty hard to innovate when you're handed a fully resolved design from a consultant, with all due respect, and the client's attached a fixed price lump sum contract to that design, and they've said, go and build that. And that design, of course, is fully resolved to the last nut and bolt. And in that sort of framework with very, very prescriptive specifications, it's extremely difficult for a contractor to have any influence on the ultimate design outcome or constructability even. So this issue of changing the way we specify things, and I like the idea of a hybrid, because I think there is a danger in going too far in the performance direction, because then you wind up tying yourselves in knots about well, or really adding a whole nother layer of administration and paperwork and testing and everything that needs to be done. So we need to do much better at bridging that gap between performance and prescriptive sort of specifications. Now, it's interesting to me that when we did this little Mentimeter at the start and we asked, where's everyone from? As far as I could tell, there was 0 asset owners on the call, which I think is telling, because from our perspective, that's where the change really needs to come from. Asset owners, client agencies who are specifying, well, who are really, I guess, signalling the appetite for different products, different materials, different ways of working. That it really needs to start with the client, because they're ultimately footing the bill, and everything flows down from there. And the way they can do that, they of course don't have to simply say, you know, thou shalt use some particular form of concrete, or even a performance-based specification of a concrete. They can play a big role in saying that we have an expectation that you will start to use innovative materials or more sustainable materials, and we expect a certain proportion of the project's inputs to be categorized in that kind of way. Whereas as it stands at the moment, it's quite, you're really pushing it uphill, so to speak, to introduce anything innovative to most client delivery agencies in most contexts, and not all. There's plenty that are plenty of people in those organisations that really want to see change. But you know, just as an anecdote, I was talking to someone up here in Brisbane working on a very large railway project. I'll let you guess which one that is. And you know, a big marquee project like that, you'd think is a perfect opportunity to really try some innovative, sustainable sort of materials. And yet the state authority was very, very reluctant to try anything new, even in a experimental kind of controlled piloting kind of way, simply because of the organisational inertia that's bound up with engineering design and certification and so on. And of course, we acknowledge that there are really, really good reasons for that sort of organisational inertia, and the kind of approach that we've had to very prescriptive specifications has meant that, you know, Australia delivers world-class built environment assets that by and large don't fall over very often. And that conservatism has built extremely robust structures. Yet, as we move into a future where we all need to get to net zero by 2050, and we're nowhere near on the trajectory we need to be to get there, and we're trying to drive productivity improvements to make sure that we can keep up with population growth and all the extra demands that come with a growing population against a shrinking pool of labour resources. You know, if we're going to achieve those two things over, say, the next 3 or 4 decades, there's no way we can do it under the current sort of paradigm. So we need to get a lot smarter about how we structure our procurements and the way we do our contracting to ensure that we can introduce materials and approaches and methodologies that I guess will get us there. And performance-based specifications is a huge part of the solution. And that's the bottom line. We need to bridge that gap and move away from the historically prescriptive specifications, drift more toward the performance-based specifications, so that we can drive sustainability and productivity. And this is not a long-term problem. This is a problem we need to solve right now. I mean, we've got to deliver an Olympics by 2032, and every single one of those venues, massive venues, need to be 6-star Green Star. How are we going to do that with regular old cement, steel, and so on? So anyway, that's I guess that's the rant from the contractor's perspective. We think there's a great opportunity to leverage marquee projects and work hand in glove with people like Transport for New South Wales, TMR up here in Queensland, And even the feds, I think, need to lean into this space a bit more to incentivise the change that we need to see if we're going to realise our ambition on sustainability and productivity. So anyway, I guess that's all I really had to say in this opening stanza. I look forward to the conversation going forward. I'll hand it back to you, Claire.
Thanks so much, Robert. Absolutely love your rant. That's brilliant. And we do have one asset owner on the line, at least. Very pleased to be joined by Transport for New South Wales, represented by David Kelly. So David, couple of things to answer to there, but we're also really keen to hear from you. So thanks for joining us.
Thanks,
I'll just
Claire.
share your slide.
And thanks, Robert. I think this is the perfect lead in. I won't say perfect, but close to. And thanks to Bruce and Jason also, you put it well that what we're doing here is adding more performance. You said to prescriptive, but in Transport's case, that's hybrid, adding more performance to hybrid. And I think Robert's right, there's a delicate balance here. But I think Transport's definitely heading in the right direction. So just to introduce myself, I'm David Kelly. I'm Acting Director Engineering. I lead the Sustainable Infrastructure Program in Infrastructure in Place across quite a diverse range of branches. So commercial performance and strategy, technical services where I work, our development branch, Sydney project delivery, regional project delivery, rail delivery, and then also portfolio optimisation and innovation. So it's quite a broad program, and Transport for New South Wales is very invested in sustainable procurement and infrastructure and decarbonisation. For some reason I can't, you can control, it's not coming up. You might have to share my, just next slide. Thanks, Claire. For some reason I don't have control. And you'll have to click through, there's an animation, keep going. Keep going. Yeah, and one more. Fantastic. So just to set some context, I'll be really quick here. So I've obviously got New South Wales Net Zero Plan, our future transport strategy, recommendation 27 in the state infrastructure strategy. We've been doing a lot of work in the operation space. Sydney Trains first to transition to net zero. Metro offset 100% of its operational electricity. But 2 years ago, we realised that we needed to change in terms of construction-related emissions and also circular economy. We set up sustainable procurement and infrastructure, and last year we delivered a discussion paper, offered a formal response to industry, held 5 targeted workshops, and then also released an industry engagement report, which Smart Creek will send out at the end of the webinar. And so I'll briefly touch on industry engagement before talking about our journey to performance-based specifications for decarbonisation. Next slide, thanks, Claire. The one after that. Great. So sustainable procurement and infrastructure. It's been almost 2 years. It's a 2-pillar approach. We've got an accelerated pilot program, which has set consistent project level emission reduction targets. M1 to Raymond Terrace behind me being one of those. And we've also piloted performance-based specifications for decarbonisation. That was done in consultation with Cement, Concrete and Aggregates Association. So it was quite a handy pilot to inform our approach. At the same time, as I mentioned, we've got one of the largest industry engagement campaigns for a corporate document at Transport. Next slide, Claire. So our co-creation workshops, so we had industry leaders come in for 5 targeted workshops. One was on those baseline sustainability requirements. The second, our roadmap to net zero infrastructure, in particular, plotting out discrete milestones on a roadmap out to 2030, 2040 and 2050. Designing for decarbonisation. We talk about low carbon materials a lot, but we don't talk about low carbon assets enough. And low carbon materials and assets are poorly correlated. We did a whole workshop on standards and specifications, the barrier, and how we're going to move to more performance-based specifications, and then also on capability, which is quite was probably one of the biggest challenges. Next slide, Claire. So as I mentioned, the slide pack, the report will go out, but there were 4 key themes raised. I'll only focus today on materials and design and standards and specifications, but I urge you to go in, read the report, and then also the associated 2026 decarbonising infrastructure delivery roadmap with Infrastructure New South Wales. Next slide. So what's the challenge here moving to performance-based specifications for decarbonising infrastructure? The first is around carbon management. So we've seen leaders such as High Speed 2 at the program level and National Highways at the portfolio level move to certified carbon management systems. And so the need here is to talk about carbon management, not just quantification or assessment as it's referred to. And so we've got a public commitment after those workshops to move our entire portfolio to a certified carbon management system. And that's set out in the 2026 Decarbonising Infrastructure Delivery Roadmap. It also has, we asked Tier 1, 2 and 3 contractors when they'd be ready to move to a certified carbon management system. Of course, our Tier 1s who were very ambitious said 2024, Tier 2, 2025, and then Tier 3 wasn't until 2027. So we've chosen an indicative time there of 2026 to have all of our contractors and the associated supply chain move to a certified carbon management system, but not before transport gets their own house in order and does that first. So it's PAS 2080 is quite impressive because it sets out requirements for the whole value chain. So as Robert mentioned, what are the asset owners and managers doing? And part of the obligations under PAS 2080 is to make sure we're being clear and transparent about target setting, baseline, leadership, and how we quantify. Next slide. So I mentioned quantification. It's just one component of carbon management. And I think industry should be applauded for taking the lead in terms of utilising digital sustainability tools. But as a result, we've got challenges in consistency and assurance to inform robust and transparent whole life carbon. So there's virtually a new carbon tool that comes on the market every week. And as you can imagine, sitting in an asset owner and manager's position, and we're trying to put emission reduction targets on projects, this is really, really challenging. And so under sustainable procurement and infrastructure, in particular our pilots, we're starting to form up what that assured approach looks like. And a great case study to see some of the challenges is High Speed 2 Euston Station. They did a side-by-side comparison with two market-leading tools, and just for a C40 and a C50 class concrete with 20% ground granulated blast furnace slag, there was a 59% difference in the emissions factors. So huge challenges. If you can imagine, if we're on a project and we've put an emissions reduction target on without changing any of the design, contractor could potentially beat that emission reduction target. So it's about working with our industry partners to find this assured approach. And so we do have a priority action in that industry engagement report, and that's to create a solution for consistent and assured LCA and carbon footprinting. And that will be updated in our digital engineering framework, because the last thing we want to do is to stifle innovation, as Robert mentioned. So our Tier 1s, they're pushing the boundary. They want to be more efficient. And so we definitely don't want to stifle that. Next slide. So transport's moved to performance-based specification for decarbonising infrastructure. As Jason put it, we're adding more performance to hybrid specifications in most cases. And so we've launched the 2026 Decarbonising Infrastructure Delivery Roadmap with Infrastructure New South Wales. It sets out a clear path for transport and our industry partners to 2026. We're in the process of rolling out that sustainable procurement framework, including minimum emission reduction targets on all of our projects. So that's just beginning now on the back of the extensive piloting. And we're developing guidance for early market engagement. As Robert mentioned, we need to start to think about this differently across both our core and complex delivery models, and also how we're designing. And most importantly, continue to work with our industry partners. Next slide. So I'll quickly touch on this, but where does carbon sit? Does it sit with a sustainability professional and we try and bolt it on into all of our standards and specifications? In my opinion, it sits with project performance alongside of cost, schedule, risk, and other functions in project performance. So that's the approach we're moving to. So moving to carbon cost management, we have an international partner that we're doing this with. And what we're looking to do is link cost, carbon, and engineering design, and have base carbon built up to PAS 2080. So this is going to give that assured approach about what really is a decarbonised solution. And we're going to get contractors to produce quantified decarbonisation plans the same way they produce cost plans using assured lower carbon alternatives. So it's a really exciting project and quite progressive in the Australian infrastructure sector. Next slide. And so what are the key actions on this roadmap? The first is that we're assigning whole life-based carbon at an item level, so specification level, and then a resource level underneath, as I mentioned, high speed 2 before, and some of the complexities underneath specifications. So think of our core specifications like R53, B80 in the concrete space, R82, R83. And then we'll be also setting carbon intensity thresholds that form the basis for our performance-based approach to net zero. And I think probably, Robert, to your point, which is key, is that this will take incentivization, and we've heard that loud and clear through our industry engagement with sustainable procurement and infrastructure. And so after we deliver that robust and assured whole life carbon management system similar to national highways, we've got a public commitment to incentivize lower carbon and circularity outcomes on projects. I'm not sure if we're the first infrastructure agency in Australia, but we do have that public commitment there to start to incentivize, to turn the dial. And that's about it for me. But I think the key here is to continue to work with our industry partners, the Cement, Concrete and Aggregates Association, ACA, and then of course Smartcrete CRC, because there's huge technical challenges here. And in my opinion, there's really probably inadequate funding for the amount of accelerated research and development that we need to do to move to that perfect balance between prescriptive and performance. A really nice hybrid approach for standards and specifications. So that's it for me. A bit of a whirlwind, but thanks for having me. And Smartcrete CRC will send out the relevant documents.
Fantastic. Thank you so much, David. That was really inspiring hearing about the work that you're doing and the strategic approach that you're taking there as well. Before we swap over into questions, and we have recorded all of your questions that you've popped in the chat, we just want to quickly whip back into the Menti. We have 2 more questions for you. That will make them very, very fast, because I know that we'll want to have a lot of these really great questions answered. So thank you so much for all of the great information that you've popped in there in terms of why we should or shouldn't adapt performance-based specifications. We'll move next to a bit of a, what do they call this? It's a sliding scale. So for each one of these questions, you should be able to grab and drag the little dot to say, essentially, who bears the risk of performance. I think this has come up in a couple of the discussions. We've popped a couple of different supply chain participants there on the list, and you can say that should be from low to high rather than strongly disagree and strongly agree. But low being strongly disagree and high being strongly agree. Who would you say bears the risk of performance? Fantastic. We're starting to see those little dots jiggle about. Yeah, fascinating. Yeah, so I think what we've heard really by listening from everyone across the supply chain today, you know, from the material suppliers through to the, you know, constructors through to the asset owners is really this is a shared responsibility, and it's something that we have to work collaboratively to deliver. So that's fabulous insight there. Thank you so much. And finally, last question, which I will pop up just very quickly. What do you see as the challenges towards adopting performance-based specifications? Again, this is a card exercise, so you can write full sentences in here. And what we might do is leave this one running in the background again. So please feel free to pop in anything that you like there, and it will just automatically pop into the system. And I'm going to hand over to Hugh from Smartcrete, who is going to go through the questions. And I might ask as well if all of our presenters could come back online so that we can all answer the questions together.
Great. Thanks, Claire. Ooh, we've got a bit of echo. Hey, there we go. All right. Hi, everybody. I'm the portfolio director here at Smartcrete CRC. In the background, we've been trying to capture as many questions as we can, noting, of course, it's already 3:30 now, so we're already at time. So this conversation's gone really, really well. As a super high level, though, I'm just going to go read through some of these questions, perhaps. And instead, what we'll do is I'll get these sort of written up in the background. I'll have a couple conversations with some of our panelists today and see if we can send out the answers to some of these questions to you instead of trying to squeeze it all within the -1 minute that I have left. So let's probably leave that there. At a super high level, there are questions about risk, there's questions about materials, there's questions about the presentations themselves, whether folks can have those. All great questions. So please keep an eye out for some communications from us. Back to you, perhaps, Chloe. Can you close us out?
I'll stay back there. That was a very fast question session. I guess, do we have any closing remarks? I know we have gone over time, but I think the thing that's come up in a few of these questions is really around risk. David or Jason or Rob, Bruce, do you have any thoughts about how we might manage risk as we transition towards more performance-based specifications?
Well, I think I think that as per the Mentimeter results come up, it is like any risk, it needs to be, specified within agreements and contracts and that sort of stuff. So it is about how far we go performance-based, and then who then owns that risk. It'll be an area. This is the area really that is going to be somewhat beyond the technical requirements of understanding concrete properties in relation to the performance. Is where does the risk lie? It's fair to say that if you're following a prescriptive specification and then the asset fails, may not be held entirely responsible for that if someone's designed it and they've done the prescription wrong. But if you've provided performance-based product, you say, we'll meet this requirement, and it doesn't, then obviously the risk moves towards the supplier and contractor as well. So challenging. David, off to you. Have you got a thought about this you can share this open forum?
I couldn't agree more, and I think we don't hear enough about hybrid specifications, and I think it was great to put that on the radar. And I think that transfer of risk and what that looks like, that's going to be a constantly moving piece as we start to move potentially towards more performance-based approach. So interested to hear what Robert has to say, but I see that as an evolving piece as we start to potentially push the boundary a bit more with performance-based specifications.
Yeah, ultimately, I reckon it all comes down to the collaborative risk-sharing model that we need to implement more widely for all sorts of reasons. But this is a great example of how we need to stop thinking about this as an adversarial, transactional exchange of risk and start thinking about it as a collective endeavour where you bring a supplier, a client, a contractor together and you say, yeah, we all agree to do it this way. And then, if it goes pear-shaped, then we've got mechanisms to deal with it fairly and reasonably. And we're doing that in a whole bunch of other domains in infrastructure now. There's no reason why we can't do it here.
Yeah, that's fantastic. And Bruce, I know you've just switched your camera off, but I think that you've really hit the nail on something that's critical for this to work, which is being able to create an evidence base to demonstrate that we are going to be able to meet the performance requirements. Anyone who's toured the Cement Australia facility will know that your testing facilities are extensive and incredible. Do you see that there's a real gap in terms of what's needed towards new testing? What do you see as the evolution of accelerated aging testing? If you're still with us. Olivia is joining us. Olivia, hi.
Hi, Bruce actually had to go to another meeting, so I'm so sorry. He sent his apologies. So
that's all right. Do you have thoughts around what we might need in terms of the future of the testing processes and protocols to be able to demonstrate that evidence that we are going to meet performance specification requirements? Sorry, can you please repeat that question? What do you think we need in terms of new testing methods to be able to generate performance data?
You want to answer?
Oh, that's a hard one, at least on my end, but I guess with greater use of SCMs, you find your porosity tends to go down in your concretes and all that. So maybe that's the route we go for future testing, finding out how how quickly, let's say, water and that gets through. At the moment, our accelerated testing, it's there. It's just it takes a bit of a while. That's my take on it. How about you, Olivia?
I think the only thing that I would probably add to that is I think what happens in the lab can be very different when it comes to what happens in the field, and I think that's super crucial. And I think Bruce touched base on it when it came to, I guess, the carbonation and the testing there, and just the unknowns regarding whether or not the results that we actually are obtaining are relevant to what's actually happening in the field. So I think that's what we will probably focus on in the next few years, if not sooner.
Yeah, brilliant. Well, excited to see some progression in that space. Thank you so much. And can I take the time again to thank all of our presenters so much for joining us today. This has been a really fabulous first look into performance-based specs and what does it mean for the supply chain. As I mentioned at the start of this presentation, this is just the start. So what we'd like to do next is bring people together who have an interest in this space for a workshop where we can actually dive into those challenges and really start mapping out what they might be and how we might work collaboratively towards adoption of hybrid or performance-based specifications. So at the end of this, we will be sending a follow-up. We'll share the slides. We will, Hugh, as you mentioned, will be working on getting answers to all of your questions. We'll share that back with you as well. And we will also be sharing a link for you to register your interest to come and participate in that workshop. So if your interest has been piqued today with all these fabulous presentations, please register your interest. We would absolutely love for you to join us in a much more in-depth facilitated conversation about what performance-based specifications would mean for us and how we can achieve that together. So once again, thank you so much for joining us today. Thank you to all of our presenters. Bruce has left us, Robert, David, Jason. It's been wonderful to hear your perspectives. Thank you.
Thanks all.
Thanks, Claire. Thanks, everybody.
Thanks, Claire.